Welcome back. I am Dr. Aris. While you're worrying about weekend plans or the price of gas, my community astrophysicists were staring at a single date, October 29th. This isn't prophecy, this is math. And that math suggests the universe is about to make a move. As a scientist, I am advising you, if there is something important you need to do it now. Because after the 29th, we may be living in a world with very different rules. The signal in the silence, at this precise moment, something extraordinary is happening just behind our star. The interstellar object, Atlas, only the third traveler from outside our solar system ever detected, is currently in solar conjunction. Simply put, it's on the far side of the sun from us, completely obscured from every telescope, every radar array we have. 5 days ago, on October 21st, it slipped into this perfect blind spot. We are flying completely blind. And this is where it gets interesting. Now, let's talk numbers. This is the raw data. Did you hear that? This is what has kept me and my colleagues awake all week. 135 AU. That isn't near the Sunday. That is beyond the orbit of Pluto. It's the deep, dark, cold water of the Kuiper Belt. At that distance, our sun's radiation is almost negligible. So, where are those 33 gigawatts coming from? The math doesn't add up unless the sun's faint radiation at 135 AU isn't the primary energy source, unless it's just the trigger. Something is on Atlas, something that has waited for millennia in the interstellar cold, just waiting for the smallest possible energy push, like walking into a dark room and flipping a switch. And we are completely blind as that switch is flipped. This is why we do science, not for what we know, but precisely for what we don't. If you, like me, believe the greatest mysteries aren't on Earth but out there, then this is the place for you. We will be analyzing the data the second Atlas emerges from the far side of the Sunday. Hit that like button and subscribe. Because the universe has just sent us a black box and it's about to be opened. The orbital anomaly. And here is what makes that math 33 gigawatts at 135 AU so unsettling. It's the timing. This raises a profound, uncomfortably unscientific question. Is this a cosmic statistical coincidence, or is something more fundamental, even intentional, at play? This is why, in my opening, I echoed the warning from my colleague at Harvard, Professor Avi Loeb, the former chair of the astronomy department. He issued a warning that is resonating louder by the day. If you want to take a vacation, take it before October 29th, because who knows what will happen? This is no longer fringe speculation. We are talking about the next 3 days. We are talking about processes that could be happening right now. Because Atlas isn't just a rock. It is systematically breaking the established models for interstellar objects. Since its discovery, it has accumulated a list of characteristics that, taken individually, we could try to explain away, but taken together, they form an unprecedented scientific puzzle. Let's look at the data. Anomaly Hashon, the impossible orbital alignment. Let's start with the most basic thing. Where it came from. Our solar system is essentially flat, pictured like a vinyl record. All the planets Earth, Jupiter, Saturn are spinning in grooves on roughly the same plane. We call this the ecliptic plane. An interstellar visitor, an object ejected from another star system, should theoretically arrive from a random direction, from above the disk, below the disk, or at any bizarre angle, but not Atlas. Its orbit is aligned to within just 5 degrees of our own ecliptic plane. It's not punching through the system, it is sliding into it, almost parallel with all the planets. For an object from deep space to randomly do this The statistical probability is just 0.2%. In my field, 0.2% doesn't just mean rare, it means you are very likely asking the wrong question. It means your random model is broken. 0.2% is a giant neon arrow pointing at the object, screaming, "I am not random." This orbital coincidence would be shocking enough on its own. But it's not even the strangest part. That 0.2% probability anomaly Hashon isn't just a statistical curiosity, it is the ideal trajectory if you wanted to design a mission. If you as an engineer wanted to access multiple planets, like Mars, Venus, Earth, and Jupiter, in a single flyby of the solar system, for the least amount of energy, you would choose this exact path. But that's just how it's moving. Let's talk about what it is. Anomaly H2, the impossible chemistry. Spectral data from the KK2 telescope shows Atlas is emitting nickel at a rate never seen in any natural comet. Let me be clear. This isn't the kind of nickel you find in an iron meteorite. This specific spectral signature on Earth only appears during highly controlled industrial processes. Specifically, the carbonyl process used in alloy manufacturing. But here is the real kicker. The data shows the nickel is concentrated within a 600 kilometers region of the nucleus, while the cyanide, another compound we detected, extends out to 840 kilometers. If both were natural ices sublimating outgassing from a dirty snowball, they must follow similar physical models based on volatility and solar heating. But they don't. The nickel is behaving as if it's part of an organized structure. It isn't leaking randomly, it appears to be venting anomaly H3. The revolutionary composition, if that wasn't enough, this is the one that broke all our models. Compositional analysis shows Atlas is only 4% water by mass. I need you to pause and understand how revolutionary that is. Comets are ice. They are fundamentally dirty cosmic snowballs. Water must be the dominant component. The fingerprints of engineering, the previous interstellar comet, 2I divided by Borisov, which everyone agrees was natural, had a typical water composition. Why is Atlas so fundamentally different? It gets weirder. The polarization of the light reflecting off Atlas is extremely negative. This is a phenomenon never observed in any comet we know of, including Borisov. This data points to unique surface or structural properties. Dirty ice doesn't do this. Regular silicate dust doesn't do this. Its surface is interacting with light in a way that natural comet physics cannot explain. Anomaly H4. The extraordinary mass and scale, and that surface is enclosing something massive. Atlas is estimated to weigh 33 billion tons. It is 1,000 times more massive than Borisov. It is 1 million times more massive than Oumuamua. With a minimum diameter of 5 kilometers, it possesses enough mass to carry significant payloads across interstellar space. The HiRISE camera on that orbiter has a resolution of 30 kilometers per pixel at that distance, 3 times better than the best images from Hubble. It's not just a rock, it is a planetoid-class transport vehicle. Anomaly H5, the enigmatic anti-tail. But for me, this is the most alarming anomaly. Between July and August, as Atlas was inbound, observatories detected an anti-tail. A comet's tail always points away from the sun, pushed by radiation pressure and the solar wind. That is basic physics. But Atlas was observed ejecting material towards the Sunday. Analysis confirmed this was not a perspective illusion. Material was actively being propelled against solar radiation pressure. The only way for this to happen is if the object has active internal energetic processes. It is not merely reacting to the sun, it is actively pushing material. It has an engine. Professor Loeb created the 0 to 1 0 scale for the likelihood of an interstellar object being artificial. Atlas scores a 4. A 4 is not conclusive proof, but in science, it is important enough to justify a serious investigation that is now using planetary defense resources. This is where the story shifts from scientific curiosity to alarming. The response from scientific and defense institutions to Atlas has been extraordinary. For the first time in history, protocols normally reserved for extinction-level threats have been activated for an object that cannot possibly hit us. Consider this data. The International Asteroid Warning Network, IAWN. This organization was founded for a single purpose: to find and track civilization-threatening objects. They do not waste resources on interesting science. They exist to prevent extinction events. And yet, IAWN has activated a 3-month intensive monitoring campaign for Atlas. This campaign began on October 27, 2 days before it reached perihelion, and will continue until January 2026. What does this mean? It means the decision was made based on the pre-perihelion data. It means the 5 anomalies we just discussed were enough to justify treating it as a potential threat. But here is the paradox. This is what makes no sense in terms of orbital physics. Atlas is not on a collision course. Its maximum approach will be 1.8 astronomical units, AU. That is beyond Mars. There is zero physical possibility of an impact. So why activate planetary defense protocols? IAWN isn't preparing for an impact. They appear to be preparing for something else. The NASA silence, and that brings us to the silence. The deafening silence from NASA. The highest resolution images of Atlas have been taken. They were captured by NASA's Mars Reconnaissance Orbiter, MRO, on October 3rd, as the object passed Mars at a distance of 190 million kilometers. The HiRISE camera on that orbiter has a resolution of 30 kilometers per pixel at that distance, 3 times better than the best images from Hubble. Those images have still not been released. Professor Avi Loeb has publicly requested access, mentioning it multiple times in blog posts and direct emails to NASA. The resulting silence is incredibly noteworthy, especially since these are the most detailed photographs of this object in existence. In stark contrast, the European Space Agency, ESA, has been relatively transparent. The ExoMars Trace Gas Orbiter photographed Atlas and published the data. Superficially, it shows a classic comet appearance, a diffuse point with a small tail, a rather reassuring image until you check the spectral analysis of that very same data. That analysis reveals exactly what we already knew. The anomalous chemistry. So where does that leave us? We have 5 anomalies, an active planetary defense campaign for a non-impact object, and NASA is withholding the best images. Physics allows for multiple explanations for Atlas's behavior, but each scenario carries profound implications for our understanding of the universe. Scenario 1, the exotic natural comet. This is the safest explanation, the one most scientists will cling to. Perhaps Atlas is just a natural comet, but one with an extremely rare composition, formed under conditions totally alien to our solar system. Other star systems have different metallicities, different formation temperatures, chemical processes that don't occur here, explaining the nickel. Perhaps natural carbonyl processes do occur deep in the core, spontaneous chemical reactions under specific temperatures and pressures, explaining the low water. It formed in a volatile poor region, perhaps near a young hot star. This scenario accounts for the chemical anomalies, but it completely fails to explain the 2 most critical things. The orbit, 0.2%. Why did it arrive almost perfectly on our plane? The timing. Why would it activate, if it activates, at perihelion precisely when it's obscured by the sun? The statistical probability for all 3 of these things, exotic chemistry, a perfect orbit, and perfect timing, to occur naturally all at once is incalculable. This scenario is weak random coincidences happen, but this many simultaneous coincidences challenge statistical credibility. That brings us to the more disturbing scenarios. Scenario 2, controlled fragmentation. In this scenario, Atlas isn't just outgassing. It is undergoing an organized disintegration, releasing internal components with distinct physical and chemical properties. This would perfectly explain Anomaly #2, the chemistry. The nickel, 600 kilometers, and the cyanide, 840 kilometers, aren't following the same model because they are not from the same source. They are different components of an internal structure that is breaking apart. This fragmentation could be triggered by the increasing solar heat as it approaches perihelion. Internal structures preserved for millions of years in the interstellar cold are beginning to sublimate or chemically react as they are exposed to intense solar radiation. This scenario implies internal structure. Scenario 3, active orbital maneuver. If some process alters Atlas's velocity while it is at perihelion, we will see measurable orbital changes in the coming weeks. A deceleration of just a few kilometers per second would be enough to capture this object permanently in our solar system. And this is the key. Perihelion, October 29th, is the ideal energetic window for such a maneuver. This is the moment of maximum orbital velocity in orbital mechanics. Any thrust applied at this point is massively amplified. We call this the Oberth effect. It's the exact technique all of our interplanetary probes use to maximize fuel efficiency. If you wanted to change your orbit for the least amount of energy, you would do it on the 29th. If Atlas decelerates, that isn't natural physics. That is hitting the brakes. Scenario 4, deployment of subcomponents. Or perhaps it isn't disintegrating and it isn't breaking. Perhaps it is deploying. Atlas could be releasing fragments or smaller subcomponents during its maximum heating at perihelion. With its estimated 3 billion ton mass, Anomaly #4, it could release thousands of smaller objects. In this scenario, Atlas isn't the ship, it's the aircraft carrier. It is using its 5 anomalies, the perfect orbit, the massive scale, the active antitail to get to the right place at the right time and seed its payloads into the solar system. So, which scenario is correct? An exotic natural comet, a disintegrating structure, an orbital braking maneuver, or an interstellar carrier? This is where the story of Atlas moves beyond the data and into the human territory. The astronomical community is deeply divided, reflecting the fundamental tensions of how science should deal with anomalies and uncertainty. Jason Wright, an astronomer at Penn State, published one of the most scathing critiques of Loeb's work. In a blog post titled simply Avi and Atlas, Wright systematically dismantled each proposed anomaly on the lack of a coma. Wright argues that Loeb misunderstood how telescope tracking works. When you track a moving comet, you keep the nucleus sharp while the background is blurred. Naturally, you won't clearly see the diffuse coma in this imaging mode. It's a technical artifact, not an anomaly. On the enormous size, Wright counters that Loeb assumed a dark asteroid like 5% albedo to maximize his size estimates. If Atlas is a comet, which is brighter, its nucleus would be much smaller, simply shrouded in a bright coma. It's not the massive bulk Loeb calculated. Loeb, of course, fired back. He argues his critics are so invested in conventional explanations that they reflexively dismiss anomalous evidence. He says it plainly. Science has a conservatism problem. Paradigm shifts are always resisted. Fringe ideas are dismissed too fast. The debate has even moved beyond the data. It's about process. Wright accuses Loeb of bypassing peer review, publishing directly on blogs and in interviews before submitting formal papers. Loeb retorts that the peer review system is too slow for transient phenomena. Atlas isn't going to wait months for an editorial committee to weigh in. This debate has escaped the academic ivory tower. Betting markets are now placing odds: 75% on a natural comet, 25% on an artificial origin. These are not scientific probabilities, they are collective human judgment. But they tell us one thing: there is no consensus. This is profound uncertainty playing out in real time. Fortunately, we don't have to argue on blogs forever. We have a clear roadmap. The coming months will provide 3 distinct opportunities to definitively solve the Atlas mystery. This is how we find the truth. Window 1, November 4th, the JUICE flyby. The European Space Agency's ESA JUICE probe will get the first post-perihelion observation flying past Atlas at a distance of 64 million kilometers. This will be our first chance to see how the object changed after its exposure to those 33 gigawatts of energy. What are we looking for? Scenario 3, orbital maneuver. If Atlas performed the braking burn, the effects will be obvious in JUICE's data. Velocity changes of even a few meters per second will be measurable. Window 2, December 19th, maximum Earth approach. Atlas will pass Earth at a distance of 1.8 AU, still very far. All major ground-based observatories will be pointed at it. But most importantly, the James Webb Space Telescope, JWST, will be brought online for this. What are we looking for? Scenarios 1 and 2. JWST can detect thermal signatures and molecular composition at extraordinary resolutions. We will know exactly what it is made of and how hot it is. Window 3, March 16th, 2025, the Jupiter encounter. Atlas will fly past Jupiter at a distance of 54 million kilometers, with NASA's Juno probe providing front-row observations. What are we looking for? Scenario 4, deployment. If the object released smaller components at perihelion, some may be on trajectories that bring them near Jupiter at this time. Juno will see them. Each of these observation windows will build upon the last. In the end, the central question is elegant and simple. Did Atlas's orbit change? If the object adheres to pure gravitational laws, we will have confirmed that interstellar comets can have surprisingly diverse properties. We will learn about formation processes in other star systems, about how different chemical environments create objects with unique characteristics. If orbital deviations appear, if non-gravitational acceleration is detected, if multiple components appear where we only expected one, we will be facing a new class of phenomenon. Not necessarily artificial, but certainly something outside our prior experience. The beauty of science is that nature always gets the final say. Atlas is about to provide that reality check in a way few scientific discoveries ever can. The obscuration ends in November. Telescopes around the world will reacquire the target. And then we will know, are we observing exotic chemistry from another star system or something that challenges current classification? Regardless of the outcome, it has already expanded our perspective. It has forced us to question our assumptions and confront our own ignorance about the vast universe we inhabit. Today, processes that could redefine our understanding of the cosmos are happening behind our star, invisible and undetectable. In 3 weeks, we will begin to see the results. Oktober 29. Perihelion, nothing happened. At least that is what Earth saw. We are still on this side of the sun, completely blind, but in our labs, nobody's working. We are just staring at blank screens, waiting. At NASA, at ESA, at IAWN, at 135 AU, in the deep silence of the Kuiper Belt, 33 gigawatts of energy are impacting Atlas. The trigger has been pulled. We don't know if it's violently sublimating as in scenario 1, disintegrating as in scenario 2, or executing a maneuver as in scenario 3. The silence is agonizing. November 3, the first signal. Atlas begins to re-emerge from behind the sun's glare. The first radio telescopes pick it up. It's still there. It hasn't been destroyed. It hasn't shattered into a cloud of debris. The 75% camp, the natural comet proponents, breathes a collective sigh of relief. See? They say. Just a big block of ice. It withstood the heat. But for those of us watching for scenario 3, this is when the real suspense begins. It's intact. But has it changed? We have to wait for JUICE. Window 1, the JUICE verdict, November 4. At ESA Mission Control, data from the JUICE probe begins to stream in. The probe had executed its flyby at a distance of 64 million kilometers. It isn't sending images, it's sending something far more critical: telemetry, velocity, trajectory, position. The trajectory engineers feed the data into the models, they run the numbers, then they run them again. A hush falls over the control room. On the main screen, 2 orbital paths appear, the blue line, the predicted trajectory, where Atlas should be had it been just a rock obeying the sun's gravity. The red line, the actual trajectory, where JUICE had just measured it, they didn't match. An engineer at Darmstadt was the first to speak. It's decelerated. My God, it has decelerated. The change was infinitesimal, just a few meters per second, but at its perihelion velocity, at that specific position, it was exactly what the Oberth effect predicted. The central question was answered. The trajectory had changed. It wasn't leaving. That tiny deceleration was all it took. It had just shifted its hyperbolic escape trajectory into a captured elliptical orbit. It is never leaving our solar system. Those 25% artificial origin odds from the betting markets just went to 100%. Suddenly, everything clicked into place. NASA silence. Those 30 kilometers divided by pixel high-rise images, they didn't show a comet. They knew it was a construct. The IWN activation, the Planetary Defense Network, wasn't tracking a collision threat. They were tracking an intentional insertion. The Loeb-Wright debate is over. Loeb was right. And now, our wait for December 1, 9 James Webb, and March 2025 Juno takes on an entirely new meaning. We are no longer observing a curious visitor. We are observing a 3 billion-ton artificial entity that just parked itself in our backyard. Hit that like button and subscribe, because the greatest story in human history has just begun.